with brain power. So the idea of this question is as follows, right? So you're given an array of questions, and it's kind of similar to a DP knapsack kind of problem, where you're either taking something or not taking it. So let's go through an example, right? So here are a list of questions. Um, if you solve a question, you get some points, but solving a question means that you cannot solve the next n questions. The n is the second element in each array. So for example, if you solve the first question, you cannot solve the next two questions. You can only solve the first and the last question. But if you choose not to solve the first question, you can solve the second question, or you can that will mean that you skip the next three questions, or you can solve the next question, and so on and so forth. So basically, the idea is pretty much very similar to a DP knapsack problem, where you're deciding whether you want to solve something, or not solve it. So how we can go about solving this problem is by having a DP array, which will tell you the score that you can get starting from a index in the array. So this does not mean that you solve the question, you solve the index for which DP is referring to. You could either solve or not solve it. So let's go through an example, right? So first we initialize, or let's just go through how the code works um, in this scenario. So we have a DP array, which we initialize it to be 0 for all elements in questions. And then we go from the back to the front of the array. At each index, we have two options, right? It is to either solve the question or not to solve it. Option one will be the case, where you do solve the question. This means that you get to solve this question, but you have to skip the next n questions. Option two is a scenario where you don't solve the question and you solve the I plus 1 question. So let's look at how we set option 1 and option 2, right? So let's say if we decide to solve this question, the score that you get from the question is going to be the question score plus the value in the DP array for the index which is next available. So for example, let's say I decide to solve, let's say I'm at index 0, and I want to solve it, but then I skip the next two questions, so I solve this question. So it's going to be 3 plus DP of whatever index whatever the index, the next available index is. Alright, so that's how we get option 1. Note that we have to do a check to see whether we are within the boundaries of the array. It's also possible that you might not exceed the boundary of the array. Another option is just solve that question and don't solve anything after that, because it's not possible, because it's out of the range of the array. So that's how you formulate option 1. And option 2 is kind of similar, which is that you don't solve this question, so you solve the next question. So that's going to be DPI plus 1, right? The current value of the question is not considered because you're not solving it. And finally, you set DPI, which is the DP of the current element, which is the maximum score you can get starting from index. It's going to be a maximum of the option 1, option 2, and the current value in the DPI, right? After that is done, then you return the first element in the DP array, which is going to be the maximum score if you start from index 0 in the questions array. So that's how you solve the question, and it is pretty efficient overall. It's a linear time and space algorithm as you're running through the array once, and it's a linear in space as well, as DP is a linear array. So thank you.